All right, and we're back. So we have to do B on example 2. So we're doing f of x divided by g of x. So again, it's f of x was 3x to the first over x to the 1/4 power. So again, we divide 3 by 1, gives us 3. Now x to the first divided by x to the 1/4. Remember, when we're dividing, we have to subtract. So 1 minus 1/4 is 3/4. So it's going to be x to the 3/4 power. So we get 3x to the 3/4 power. All right, now let's talk about the domains. For f of x, there's no restrictions on this domain. So when you're saying no restrictions, you draw this R. It's a script R. It means all real numbers. On the g of x function, there is a restriction because we got the 4th root. So it's an even root. So this one is x has to be greater than or equal to 0. All right, so again, restrictions carry over. So for A, our restriction for A is, well, we're using the g function, so we're going to start with the x is greater than or equal to 0. When we do multiplication, we don't cause any further restrictions. There's no further restrictions in that. So our restrictions on the domain would be x would have to be greater than or equal to 0. All right. For B, again, we're using both the f and the g function. So again, we're going to start with our restrictions. We got to say that x is greater than or equal to 0. Now we're dividing. Division causes a further restriction because we can't divide by 0. So in this case, x can't be 0. All right? Because if that was a 0 at the bottom, we'd be dividing by 0, and we can't do that. So that causes a further restriction in our domain. So now this domain, we got to get rid of the or equal to. And now we just got to say that x is strictly greater than 0. And this didn't cause any further restrictions. So x is greater than 0. That is our restriction on that domain. All right. Next thing we're covering is a composition of functions. All right. This is the new thing for you. This is f of x of g of x. All right. So you have to make sure you're following the order because f of g of x is not the same as g of f of x. They're two different things. All right. So I would highly recommend you do this step by step because that's the only way you really can get this down. All right. So the way I do it is this. Don't do anything with the outside function. So I'm going to leave that f of. But the inside function, you can change that to what it's equal to. It's 2x minus 1. So we take out the g of x. We put in what it's equal to. So 2x minus 1. Now we take out the outside function. All right. So we're going to get rid of this f of x. We're going to put what it's equal to, but we're going to leave out the x and just put parentheses. So it looks like this. 3 parentheses to the negative first power. Now, what we put inside the parentheses is what's up here in these parentheses. So we just bring down our 2x minus 1. All right. Now, we can't leave that as an answer. We have to simplify it. We have a negative 1. That means we make it into a fraction. The 3 is in the right place, so it's going to stay right where it's at. This is in the wrong place because it has a negative exponent. So I'm going to move that 2x minus 1 to the bottom. And we get our answer that f of g of x is equal to 3 over 2x minus 1. All right, now we got g of f of x. All right, so again, outside function, just leave it as it is, g of. Inside function, get rid of it, put what it's equal to. So in this case, it's 3x to the negative first power. All right, now we take the outside function, we rewrite it, but we leave out the x and just put parentheses. So it looks like this, 2 parentheses minus 1. All right, and then we drop this down, and then we simplify. So we can multiply, so 2 times 3 to the x to the negative 1 gives us 6x to the negative 1 minus 1. And this we have to make into a fraction. So with this part, we make into a fraction. The 6 is in the right place. This x is not, goes in the bottom, and then minus 1. So we get 6 over x minus 1. All right, now with composition of functions, you can also do f of x. All right, so again, outside function, just leave it. Don't do anything with it yet. Inside function, get rid of it, put what it's equal to. So 3x to the negative 1. Now, outside function, going to get rid of it and put in exactly what it is, but leave out the x. So it looks like this when we started off. 3 times x, which we take away, to the negative 1. Now, we've dropped this down. All right? So now we have to distribute our negative first power. And again, we've distributed in, gives us 3x to the negative 1. Then power to a power multiply, negative 1 to the negative 1 gives us positive 1. All right? So now that gives us, again, we make it into a fraction. This 3 is in the right place. That 3 is not in the right place, goes in the bottom. And that x is in the right place, so it stays up top. And then the 3's cancel out, so it just leaves us with x. All right? So now we got to do the domain for each. All right. Any restrictions on this domain? And the answer is yes, there is a restriction. Because this 3x to the negative 1 would really be, we turn it into a fraction, and it gives us 3 over x. X is in the bottom, so x cannot be 0. So that is a restriction on this. X cannot equal 0. Any restrictions on this? And the answer is no. So that is all real numbers. All right. So now we're doing f of g of x. So we're using both the functions. So we got to use both of these. And that one is the one we're going to use. All right. Because that's not a restriction. All right. So we start off, again, our restriction that x has to be not equal to 0. Okay. Now, this isn't going to cause us any further restrictions, but this does, because now again we got an x in the denominator, so we got to figure out, well, what's going to give me a 0? If x is what, will that be a 0? Well, it turns out that if x is 1/2, because 2 times 1/2 would be 1, 1 minus 1 would be 0. So x can't be 1/2 either for this one. So that is another restriction. So x cannot be 0, x cannot be 1/2, can be anything else, just can't be those two. Okay? All right. B, the restrictions here. Again, we're using both functions, so we got to start off with our x does not equal 0. This doesn't cause us multiplication, doesn't cause further restrictions. And then our answer, we have an x in the denominator, and we already said that x can't be 0, so that's not further restriction, that's just the original restriction. So no further restrictions on there. All right, and then we go to C. Again, we're using the f function, so we start off with our restrictions that x cannot equal 0. And this doesn't cause us any further restrictions, and that doesn't. So that's our restriction for that one, is x cannot equal to 0. All right, so you have to worry about the restrictions on the domain when you're doing that. All right, last one. All right, using composition of functions. So we're going to use composition of functions. Now, when we do it for 25% off, really rewrite the function for what it is on. So we're going to use composition to find a total discount. All right, so first off, we got that sale. All right, so that's going to be our f of x function. So we write it not in terms of what it's off, of what it's on. So it's 25% off. That means it's 75% on or of the price. So we do 0.75x. All right. And then our 1 day additional one, all right, that'll be our g function. And again, if it's 10% off, that means that it's 90% of, so we'd make this 0.90x. All right, so there's our two functions. So now it says use composition of functions to find a total percent discount. So we're going to do f of g of x. And again, f of g of x, we leave the f function there. Take out the g function, put what it's equal to, 0.90x. All right, then we take out the f function, rewrite it, but leave out the x. So it looks like that. Now we bring what's over here into this function. So 0.90x. All right. And then all we have to do is multiply those. So multiply those two together. We do 0.75 times 0.90. And we get 0.675. So it's 0.675x. And that's what the composition of functions, that's what your total discount would, or total percent discount would look like. All right. So now to find the price of a sale price of a $40 sweater, we would do 0.675 times 40. And this would give us the new price of that sweater. And the new price of that $40 sweater is $27. All right. So that's composition of functions. All right. And you will be getting a homework assignment on this. I will write the homework assignment in the email I sent.